Going on to section 2 of chapter 6, we're going to deal with operations, properties, and then applications of real numbers. So the first thing we're going to do is add real numbers. Now, the parts that we're adding are called the addends, or the terms, and the results that we get are the sum. That's pretty straightforward. Now, there's two types of numbers that we're going to add, and if they're both the same sign, like plus 5, we're just going to add them and we get plus 10. Now, we don't write the plus if it's plus, except between the terms we have to indicate what sign we have. We wouldn't write this first plus. Now, if the other two numbers were like negative 5 and negative 5, and we were to add these two numbers, we could put like a plus sign there and put a negative sign there. So we're adding a negative 5 and a negative 5. The rule is we use the absolute sign or the absolute value of these numbers, which would be a 5 and a 5, which would be a 10, and then we add the sign that we're using. They're both negative. Or negative 5 and negative 5 are negative 10. Now, it's when they are different signs, and we have, let's say, a negative 10, and we're going to add that to a positive 5. So the rule is, again, take the absolute value of 10, negative 10, which is 10, and 5, subtract the smaller value, which is the 5, from the 10, get a 5, and then apply the sign of the larger absolute value, what that would have been a negative. That's the official rule. Some can just do it this way. Negative 10, positive 5 is a negative 5. And again, if you're using your calculator, this works out very well. So here are some general examples. Absolute value of negative 12 is 12. Absolute value of negative 8 is 8. They both have a negative sign. So if we were to add these together, it would be 12 plus 8 is 20, and then we add the sign since they're the same. Now, if you have one that's negative, one that's positive, take the absolute value of each one. That's a 17 and 11. Subtract the smaller, you get a 6. But then you apply the sign of the larger absolute value. Or if you put that into your calculator, this is what you get. Now, as we do these, notice that here we have two negatives that we're adding together, so it's just a larger negative value. Again, they're both negative, just a larger negative value. Here one's negative, one's positive. So we subtract the smaller from the larger, get a 3, use the sign of the larger absolute value, which is positive. Here again, 16 and 9, subtract the 9 from the 16, get a 7, use the sign of the larger absolute value, which is positive. Subtract a 12 from a 16, get a 4, use the sign of the larger absolute value. Here these are an additive inverse. Now when we subtract two numbers, that is called their difference. So A minus B. And A is the minuend and B is the subtrahend. Haven't seen these words in a while, but they are there. and compare the two below. Here, if we subtract a 5 from a 7, we get a 2. Here, if we add a negative 5 to a 7, we get a 2. So these two are equivalent, except this is subtraction and this is addition. So often we can change subtraction to addition by putting a plus sign and making the negative 3 in parentheses as a distinct unit. So the rule is we can always do this. That's the definition of subtraction. We can change every subtraction to an addition. So there's a subtraction. We're going to change it to addition and then make the b that before was positive a negative. That is, we changed its sign. These are equivalent. So we have the option here of changing this to addition. It would be 6 plus a negative 8. Negative 12 plus a negative 4. That didn't come out too well. Now here's where it gets a little tricky. The opposite of a negative is going to make this a what? From an earlier lesson, a positive. The opposite of a negative makes it a positive. Two negatives make it a positive. So this will be a negative 2. This is going to be a negative 16. This is going to be a positive 7. And this will be an 18. And the details of it are down below. Where did I mess up here? Negative 10. Oh, that's not a 17. Sorry about that. I got a little confused. All right, let's. Now, when we are doing the operation multiplication, the things we are multiplying are the factors, and the results are a product. So here we see, and we can indicate multiplication by putting a dot up in the middle between two numbers. And here it's the product decreases by 4 each time. Notice what's happening here. Now, keep this in mind. We're going to use that later in other chapters, where they're asking us to see if we can figure out the pattern of what's going on. So if this is 0, if we now multiply a 4 by a negative 1, what will this be? And following the pattern, it's going to be a negative 4. So the rule for sign factors, if both signs are the same, that is, they're both plus, that will give you a plus as a product. If they're both negative, that will give you a plus. So we say like signs give you a plus. Now if they're unlike signs, one's positive and one is negative. Unlike signs, that gives you a negative. And here we see it illustrated there, negative. And they're continuing the pattern. And they're giving us a lot of examples here. Now, if you are multiplying again two negatives, the pattern would be that it's a positive. So two negative factors, two positive factors give you a positive. If one is negative and one is positive as your factors, the results, the product is negative. Unlike signs, negative. Like signs, positive. Let's go on. And there's the rule, and there's the symbolic expression of the rule. So let's do some examples here. As we look at the first one, one of the things I always suggest is, what will the end sign be? Well, unlike signs, this is going to be a negative. Unlike signs, this is going to be a negative. Like signs, this will be a positive. We don't write the positive usually. And here they're giving us the answers. So this is going to be a negative 63. This is going to be a negative 70. And this will be a positive 32. They've given us some easy ones to work. Now, the next operation is division. The results of dividing two numbers is called the quotient, where we have like A divided by B or A over B, and we're giving this quantifier. You can't have a denominator be a 0. In our math system, this is undefined. And we'll probably hit that again shortly here. So A is called the dividend, B, or the numerator, yep. B is called the divisor, or the denominator. In this form, it's the dividend and the divisor. In the fraction form, it's the numerator on top, denominator on the bottom. And we say if A divided by B equals C, then A equals B times C. We call multiplication and division related processes. Now, the rule for the signs when we divide, if they are like signs, both negative, both positive, the result, the quotient, is positive. If one is negative and the other positive, doesn't matter where they are, then the results are negative. So here one is negative, so the results are negative. Here both are positive, so the results positive. I'm sorry, both are the same, the results are positive. So again, a summation of the rules, dividing real numbers in terms of their sign. Like signs, the results are positive. Unlike signs, the results are negative. So when doing division of sign numbers, again, a useful tool, what will be your end sign? Here they're unlike signs, so it's going to be negative. Like signs, the results will be positive. Unlike signs, negative. So 5 into 15 is 3. 25 into 100 is 4. 3 into 60 is 20. And the solution is below. Now, some general rules of 0 in calculations. Anytime 0 is divided by something that is not a 0, the answer is 0. It's not 0 over A. That's the beginning of it. The answer is 0. Now, how about if you divide any real number by 0? Well, in our number system, if we tried to multiply A times 0, we'd get 0. But now if we multiplied 0 times 0, that wouldn't give us a 7. So this is not a 0 here. And we say, what is that? Well, this is a unique quotient, a unique division, And we say whenever you have this throughout the rest of the course that this is not the answer. 7 divided by 0 is not the answer. That was your result of the work. The answer is that it's undefined. And that is the answer. So unfortunately, if you put that in Math Lab, they're going to count it wrong. You have to put undefined. Okay. So here is the definition. Anytime you have a real number divided by 0, it is undefined. Anytime you have 0 divided by a real number, that is, the answer is a 0. Okay? Now, we're getting into what is called order of operations. And many students from the past have heard something like this. Please excuse my dear Aunt Sally. Now, these are the first letters of what I've just said. Please excuse my dear Aunt Sally. But they're also closely related to, in mathematics, the order of operations. That is, as you find a series of terms and numbers and expressions in math, you do the parentheses. What's inside the parentheses are grouping symbols first. Then you raise exponents. So there's no more exponents and grouping symbols. Now there may be multiplication and division. That's what you do next as you come across it. If division is first, you do the division. If multiplication is first, you do the multiplication. And then finally at the very last step, when there's no more grouping symbols, exponents, multiplications, or divisions, and these are all from left to right, you do addition or subtraction if subtraction is first. This is the order of operations. Now, there is a number of different grouping symbols. The most common, of course, are parentheses. Another grouping symbol would be absolute bars. Another grouping symbol would be a fraction bar. And then for parentheses, there's sometimes brackets and braces. But these are all grouping symbols. And we'll see this as we go on to some example. And here we see it summarized as well. Work separately above and below a fraction bar, because that is a grouping symbol. And then parentheses or square brackets, you start at the innermost and work outward. Then exponents. Then multiplication, division, again, whichever comes first. And then addition, subtraction. One of the big errors I see in my math classes is that students do not distinguish between this and this. So when we have an exponent, such as 2 to the 6th, the base of that exponent is the 2. When we have something like this, negative 2 in parentheses to the 6th, the base of that exponent is the negative 2. And they're showing you the difference here. Because if you have a negative that you're raising to the 6th power, an even exponent, then your answer is going to be positive. If it were an odd exponent, it would be negative. Now here, what is your base? Your base is just the 2. So this is what you have. And then finally, you apply the negative sign. So the difference between these, again, are the difference between a right and wrong answer. So notice, this is going to be a positive 2. This is going to be a positive 64. A positive 64. And this is a positive 64. But if we put a negative sign in front of this one, this now, as you expanded this, became a 64. Then we apply the negative sign, so that would be a negative 64. Okay, let's look at some specific examples now. So if need be, I'll write them out over here, but hopefully you can follow. So what do we do first here? Well, we do our multiplication. So this is going to be 6 plus 5. This will be an 11. So that one was sort of easy. Now, for this one, what do we do first? Do we multiply, do the exponent, or do what's in the parentheses first? Well, what's inside the parentheses. So this is going to be a negative 10 here. Now we raise this. 3 to the second is 9. And we have 4 times 9 plus 7 minus 10. So we're going to do the multiplication. 4 times 9 is 36 plus 7 minus 10. So now we're going to add 7, get 43, minus 10 is 33 for this one here. So this was 43 minus 10. Now in your homework logs, you want to write these out carefully. I'm not modeling them very well, but we're using this space to show you the process. Now for letter C, I'm going to kind of do it over here. So what do we do first? Well, what's in the parentheses? So 8 minus 12 is going to be 2 times a negative 4 minus, now we can do this here too. This is a 44. And then here we're going to do this multiplication. This is a negative 10 minus 3. So I can convert this to a negative 8 here, save us some room. So I now have a negative 8 and a negative 44. That's going to give me a negative 52 over a negative 13. Now a negative divided by a negative is a positive, and 13 goes into 52 and even 4 times. Now letter D is a little tricky, because once again, what is the base? The base is only the 6. And 6 to the 4th is 1,296. Have my calculator handy. But now we must apply the negative. So that's that. But this next one, letter E, this is a negative 6 is the base. So a negative raised to the even exponent number 4 is going to end up being a positive, because negative times negative is a positive, times a negative is a negative, times a positive is a positive. 1296. And your books do show that in some detail. Now from letter f, what do we do first? Well, the innermost parenthesis. So what we have here is going to be a -3. But it's the opposite of a -3. So this becomes a positive. So we have 4 plus 3 is 7, and that'll be a -7 there. Now we have a negative times a negative. This is going to give us a positive 24. So 24 minus 7 is 17. Now again, you can follow what is shown here. This is actually a good modeling of what we expect in your homework logs and on your test to show the work to get full credit for your answers. So let's go on. And as we scan through the answers, you can see what they are like. Okay, next page. Properties of addition and multiplication of real numbers. Well, again, since you can use your notes, this is going to be very useful, but other students have had to memorize this. So let's go through properties of real numbers in addition and multiplication. So, closure property. That is, A plus B, the addition operation, and A times B, the multiplication, are real numbers. So they're in the real number system. The commutative property of addition says that we can add A plus B and just switch around the order, B plus A. That's true for multiplication, AB, BA, and addition. The associative property, I like to show it this way. A plus B plus C equals A plus B plus C. The order is exactly the same. The difference is where we place our grouping symbols. Here we're adding the first two elements, then the third. Here we're adding the last two elements, then the first. The order's the same, but the grouping, how we associate, is different. That's the associative property of addition, associative property of multiplication. Identity property. We can add any number, to any number, a 0, and it always just stays the number. And we can do that in any order. That's part of the commutative property. We can add a 0 to anything. It doesn't change its value. So that's the identity property of addition. Now the identity property of multiplication is we can multiply anything by 1 and it doesn't change its value. We're going to use that in the future. Now the inverse property we've talked about is you can add its opposite, and the sum of a number and its opposite is 0. And that is commutative as well. You can switch the order around. So adding a 0 to any number doesn't change its value. Now, we said we also have an inverse property of multiplication, that if we have the letter A, what can we multiply that letter A by so that it equals 1? And the answer is it's multiplicative inverse. Now every number that we write is over 1. Interestingly, the inverse, the multiplicative inverse of a number, just flip it. It would become 1 over a. Notice now when you multiply, you get a over a, and that is equal to 1. Or you can just cancel out this a with this, and you get 1 over 1. We don't write the 1 over 1, we just write it as 1. This is the multiplicative inverse property. This one is the addition inverse property. Adding 0 stays the same. Here, the multiplicative inverse, what can we multiply something by so that it ends up being 1? And the answer is its reciprocal, that is, flip it over, or its multiplicative inverse. And then we have the distributive property in respect to addition, where we have a, and then in parentheses b plus c, where we just multiply these two together, get that, and these two together, and get that. And we could do it backwards too. B times a gets this, c times a gets this. Now, something you might want to note at this stage is this is the distributive property. Suppose you have something like this, and you want to get back to this. What's that property called? That's a star question here. Anyone know? Well, it's called factoring. We factor the a, which is a common factor in these two terms, so that it looks like that. This way it's distributive, this way it's factoring. Now we say it's a closed set because we're using real numbers for this. Here are the rules, sort of summarized, of what we just gave in lecture. So there they are in your textbook, nicely written out and summarized. So here is where your notes come in handy as reference. What is this showing? That 5 plus 7 is a real number. This is the closure property of addition. Here we have 5, 6, 8, 5, 6, 8. The order's the same, but the grouping symbols are placed differently. This is the associative principle. Here we're adding 0 to 8 and getting 8, the identity of addition. Here we're getting a product of 1. We're starting with this, multiplying by its reciprocal. This is the multiplicative inverse property. Now here we have 4, 3, 9, 4, 9, 3. So what's happened here? We've taken these two and switched them around. This is the commutative property of addition. And this, you recall, is the distributive property. Okay. In this part, they're giving us some problem-solving strategy. When we're dealing with English and changing it into mathematics, what's a gain? What's a loss? Well, gains would be positive, loss negative. In the black, that's positive. In the red, that's negative. And then above sea level, below sea level, and then temperature above 0, below 0. And we're looking at some things. So how about this expression here? Subtract this from that. So how would you write that? Well, you have a 54, better. we want to subtract that. So we put a minus sign in front of it. Subtract 54 from 68, and that will equal 14. Now, that's just translating from English into arithmetic. Now, another way of thinking of that is 64 minus, all right, I'm getting that, 68 minus 54, the old-fashioned way, still gives you the 14. Okay. Now, how about subtract, switching things around? Subtract this from that, so here it would be subtract 68 from 54, and that will give you a negative 14. And you could do that a similar way, where we take the absolute value of this, the absolute value of that, subtract the smaller absolute value, get your 14, then use the sign of the larger absolute value. Okay? So it's something we've worked on, and it's practice now. Now remember, in something like this, when we're taking absolute value of something, we need to determine what is inside before we take it out of the absolute signs. Remember, it's either going to be a zero, unsigned number, or it will always be positive. So let's look at example 7 here. And suppose you are an employee of a fund management company, and you come across the results shown in figure 8, which is down below here, which is this one, in a trade publication. The amounts are rounded to the nearest percent. Okay. Well, what are they asking us to do here? Illustrate by subtraction and absolute value how to determine the change in percent of annual returns from this year to this year, and then later from this year to this year. Well, if we look down here, I don't have to write every one out. There is for A. Now notice a loss is negative, but you're subtracting these two, so eventually this becomes a positive. So your total distance between this, a negative 28 and a positive 8, is 36. Okay? And since this was a loss, that would have been a negative 36. And in letter B, again, from those years, a negative 28 and a negative 30 gives you a negative 58. So this is out of the absolute sign as a positive 58. Another way of looking at that would have been the opposite of a negative 28 made it a positive, and there is your results. So looking at the example A, was from here down to here, what kind of loss was that? That's where we get the negative 36. So the distance between that is 36, and it was a loss. Okay. Well, in this last example, we're looking at, let's say, Eli. On this day, it was negative 22. So it was a decrease by 4 degrees. In I'm not sure how to say that. Anyway, now it went from a negative 20, it actually went up 2 degrees. And that's basically what they want you to do, and they're showing you how to do it. Increases in temperature are plus, less temperature would be negative. All right, now here are some examples. We might have time to do it. If not, we'll let you go.